Okay, so we have to solve the following circuit. So we're told that the following circuit, it's been closed for a very long time, and as it opened when t is equal to 0. Now we have to find the formula for this voltage at the capacitor when t is greater than or equal to 0. So for now, let's go before t is 0, so t less than 0. We're told it's been closed for a long time. So the circuit, this thing will be closed. Okay? Now since that's closed, we know the current passing through the capacitor is equal to the capacitor value times dV over dt. Since it's been a very long time, t is infinite, so the capacitor value is 0. So that means there's an open wire here. But now, but to find Vt when t is greater than or equal to 0, the formula will look like this. Okay, so we have to find V0. So V at t is equal to 0. So this is how we're going to solve it. So let's redraw our circuit. All right. So this is an open wire here, but that doesn't mean that there's no voltage here. There's still a voltage at this region. Okay, and since there's no current passing through here, this resistor is pretty much can be represented by a closed just a regular wire. So that means we need to find the voltage at this point. Okay, so this is 20 volts, this is 3 ohms, and this is 9 ohms. Now, if you do a mesh analysis, you get the current to be 1.6667, and 1.6667 times 9 will give you the voltage at this point. Okay, there'll be 15 volts here. So that means V when t is less than 0 will be 15 volts. But we need V when t is equal to 0. So let me erase this circuit. And let's go to when t is equal to 0. So when t is equal to 0, the circuit looks like this, and we have our capacitor back. So what does this mean? Well, when v is equal to 0, when when t is equal to 0, v at t equals 0 will still be 15 volts, because the voltage at a capacitor can't just change instantaneously. It has to start changing at a steady pace and everything. It just can't just suddenly like change instantaneously. So with the second t is equal to 0, the voltage at that time is still 15, and then it starts changing. Okay, so we already have that done. So this one will be Vt equals 15 e to the power of t over the time constant. Now the time constant is what we need to find. The time constant is R equivalent times the capacitor value. So now we're focusing on this circuit. When t is equal to 0, this is open, so that means there's no current passing through here. So we can just ignore this portion of the circuit and redraw it like this. Okay, so the resistance equivalent will be between the capacitor terminals. So the resistance equivalent is just 9 plus 1, which is 10. So it'll be 10 times the capacitor value. So the capacitor value is 20 millifarads, and divide that by 1000, that's 0.02 fards. And so the time constant will be 0.2. Now we have enough information to find our formula. So our formula will be Vt equals 15 e to the power of t over 0.2. Alright, so that's our formula done. Now it asks us to find the energy stored in the capacitor, the initial energy stored. So the part initial means when t is equal to 0. So V at 0 is equal to 15. So to find the energy stored in a capacitor is equal to 1 over 2 the capacitor value times voltage squared. Capacitor 0.02. The voltage at t equals 0 is 15 squared, and that's 2.25 joules. And that's it.